Welcome to the pre-calculus notes for Essential Skill F4, graphing secant, cosecant, tangent, and cotangent. This video assumes that you've already completed the detailed graphs, and we're just going to review what how to derive the anchor points, and then the general shape that we're going to use, and then transform later. For cosecant, we're still using the quadrantal angles. Remember that cosecant is the reciprocal of sine. So here are the values of sine. Cosecant is going to be 1 over sine. So 1 over 0 is undefined. 1 over 1 is 1. Once again, we're undefined. The reciprocal of -1 is -1. And we have 3 undefined spots. The anchor point, I'm going to take some liberties with the notation just so that we have something concise. We're going to have 0, comma, u for undefined. So the general shape that you should have found is that everywhere that we have an undefined value, we ended up with asymptotic behavior. So the general shape is going to be asymptote, asymptote, asymptote. The detailed graph should have shown you that the general shape is kind of a set of alternating U's, or arches. The midline passes right in between them and does not intersect either of them. But it does represent a median of sorts. How do we find the median value? Well, we look at this local minimum and this local maximum, and we average their y-coordinates. That'll get us that midline. Now, what do I mean by local minimum and local maximum? Well, clearly, this is a minimum point compared to the points around it. It is not the minimum value of the function overall. We've got much lower values over here. But in its little neighborhood, it is the minimum value. It is only locally a minimum. So that's where that comes from. On the right, we have a local maximum because this is at the top of its little neighborhood. Even though it's not the highest point around on the whole graph, it is locally the top. To graph this with anchor points, we're going to follow roughly the same procedure that we did for cosine and sine. We're going to plot the y values. Our y values, our local minimum is going to be at y equals 1. Our local maximum is at y equals -1. Our midline is at 0. And we're going to have 5 points. 1, 2, 3, 4, 5. We'll label these. One thing that can be very helpful is to graph this as if it were sine first. Use that to come up with some reference points for cosecant. A graph of sine of 0 is 0, sine of 1/2 is 1. We get something like this. To turn that into a cosecant graph, we look at what happens. Every time the sine is 0, the reciprocal doesn't exist. We get a vertical asymptote here, here, here. Our actual cosecant graph is going to intersect the sine graph at its maximum. That actually becomes the minimum value of cosecant. and then we'll obey the asymptotes. We get arrows because this asymptotic behavior suggests that it's going to continue forever. At the minimum of sine, we have the maximum, the local maximum of cosecant. And that's it. That's one cycle of cosecant as a parent function. Let's look at secant. Once again, we have the quadrantal angles as our inputs. Secant is the reciprocal of cosine, so let's get the cosines. And here are the secants. 1 over 1 is 1. 1 over 0 is undefined. And so we'll write our anchor points, like so, using the x values. Our general shape is going to be approximately the same as cosecant. It will just be offset in the same way that sine and cosine are offset from each other. So we actually have two asymptotes. We start, our first anchor point is at our local minimum. So it's going to look like this. Once again, the midline does not touch any of these arches. And strictly speaking, I'm only drawing in this part of the arch for completeness. Our cycle actually starts here and ends here. How do you find the median value? Well, the median value is simply, once again, the average of the local minimum with the local maximum. Local minimum, local maximum, local minimum. Let's look at this with our anchor points. Once again, we'll start with a very light graph of cosine, just to use as a reference. To get our secant graph, we look for where the cosine would be 0. The reciprocal of 0 doesn't exist. That's where our vertical asymptote lies. This vertical asymptote is going to show up anytime that the cosine graph would cross the midline. Now we complete the graph. Strictly speaking, our cycle starts at 0, comma 1, becomes asymptotic. We get a downward hoop. We end with an upward hoop. Again, this is a complete cycle, but I think it looks a little better if you complete the hoop. I think it conveys more of the shape. This part is optional. We're going to cover tangent and cotangent in class because that's going to take a little more discussion, and then we'll take a look at transforming them. And that will be it for Unit 6. Thanks for watching.